Hey, what's up? My name is Alan Tran. I'm a senior civil engineering student at UT Austin, and I'm a concrete canoe captain, and this is...
Yeah, I'm Boris Vilic. I'm also the other canoe captain. I'm a civil engineering major and I'm a senior.
But Boris, what even is concrete canoe?
That's a great question So Concrete Canoe is a competition hosted by ASCE on a regional and national level. So a lot of schools will get together, make a concrete canoe themselves, a canoe made out of concrete, and then race them in some kind of body of water to see like who has the nicest canoe and who's able to like beat everyone else in the race.
But does it float?
It sure does. How else would you compete? So, how far along are we in the process? How built is our canoe?
Our canoe is pretty built right now. We only have a few more finishing touches to do, but we're at an important stage in the process called curing. So a little fun fact, once you make the concrete, after it's poured, you actually have to wait a day, and then you actually need to soak it in water. So concrete is actually very weak if you just let it dry, because water is needed for some chemical reactions to happen it'll just make the concrete stronger. And that's what you want, because if your concrete's weak, then it's going to break in the water, and then all the other teams are going to be laughing at you. So what we did was we put humidifiers underneath this plastic tarp, and that will just release constant moisture into the air. It gets trapped underneath the plastic, and that moisture that's trapped will make sure that the canoe is constantly moist, and that the canoe's getting the water that it needs to become as strong as it possibly can be.
So, when you want to design your canoe, you want to keep in mind what you want it to be good at. You want it to be fast, you want it to be good at turning. When you're in it, do you want it to rock a little bit or not rock at all? Like, these are all important things to keep in mind when designing the canoe. So you can make the shape boxy or curvy, and that'll have an influence on like what it's good at. So once you decide what you want it to do, you start by designing the cross sections at certain lengths in the canoe. So once you've got those important cross sections taken care of, you can export it into some kind of 3D design software to see what it would look like as one cohesive piece. So you can kind of see here, like at each section, there's like some points that define that cross section, and then like it comes all together.
Right now, we're in the wet room, so basically imagine that this is what's happening inside of the tarp that was shown earlier. We would like to put the canoe in here, but obviously the canoe is like 19 feet long, so it's not going to fit inside this room. So we have to go with that setup. But ideally, whenever you test concrete, you put it into cylinder shapes, and then you can break those cylinders later to find out how strong it is. So in order for cylinders to get maximum strength, we put them into the curing room, like so. That constant moisture is constantly dripping out. It'll always be humid in here, it'll always be moist, and then the water will seep into the concrete, get used for chemical reactions, and gain the maximum strength you can possibly get. A little fun fact, at 7 days, you get about 65% of your max strength, and after 28 days of being inside this room, it'll be at about 99% of its maximum strength. So generally speaking, the only days that you want to test your concrete is at the 7-day mark and at the 28-day mark. So whenever we make the concrete for the concrete canoe, we need to test some of its properties to make sure that it can actually, be strong and flowable enough. So one of the tests is called the Slump flow test. It's basically, imagine filling up a cone with concrete all the way up to the top. And then you just lift it up. And you're just trying to see how far that concrete spreads out. And that tells you about how flowable it is, which is actually pretty important, because if you're placing concrete by hand, you don't want it to be flowable like at all. But if you're just pouring the concrete, then you want it to be extremely flowable. So knowing the difference between the two is really important whenever you need to make the canoe.
Thank you so much for showing up for our presentation. We hope you enjoyed learning about concrete canoe.
And if you're interested in joining a concrete canoe team in the future, most universities have them. We encourage you to go give it a shot. It's really fun. You just got to give it a chance.
You got to learn a lot and make new friends.
All right, bye.